Well, we're going to be spending the next 90 minutes or so on a panel discussion. And our focus is going to be how to improve collaboration and innovation flow in canola. The panel discussion in this section is generously sponsored by Sask Oilseeds, so we thank them for the sponsorship. And to kick this off, all of us were inspired by a presentation from Dave Charne at last year's Canola Week. And because of that inspiration, we decided to expand to include a 2-hour discussion or one and a half hour discussion on public-private partnerships in canola genetics. We're going to have 90 minutes now, and then we're going to have 30 minutes after lunch as well for final thoughts, takeaways, and next steps. I'm happy to introduce the moderator of this session, Sheri Strydhorst. Sheri has over 20 years of experience in research. Sorry, I got to get I'm missing my podium here, Sheri. I'm going to start this over again. Sheri has 20 years of experience in research in the agriculture industry. She believes in research that aligns with grower needs while upholding scientific rigor. For the past decade and more, Sheri's been a research program manager for crops at RDAR, Results-Driven Agriculture Research in Alberta. She also farms with her husband Shane in Nearlandia, Alberta. Sheri's going to introduce the participants in this session and moderate the flow. Thank you.
Thank you, Curtis. Okay, we've got the technology figured out here. So I'm really thrilled to be here. And, part of my work, I have not worked in canola. This is relatively new for me, but it's really finding that strategic role. As Richard said, we have decreased investments in research. So how do we make the most of those, and how do we make those investments flow from those public researchers to the private firms? And I'm going to let each of the panelists here introduce themselves. So I'm going to start with Jed Christianson from Bayer Crop Science, and he can give an overview of himself and what he's going to bring to this panel.
Sure. Yeah, this works. So I'm Jed Christianson. I've been with Bayer Crop Science for about 15 years. Prior to that, I had some experience as a postdoctoral fellow with Agriculture Canada in London, Ontario, with the CSIRO in Australia, and the University of Alberta before that. I graduated from the University of Alberta in about 2003, where I'd done research on canola and resistance to blackleg in that pathosystem. So currently with Bayer, I'm involved in a team that delivers breeding innovation to our breeding pipelines, and is involved in things like sourcing novel disease resistance traits, adapting new technologies and techniques to a large-scale breeding pipeline.
Thanks, Jed. And now we'll go over to your counterpart, Dave Charne and Corteva Agriscience. And you sound like you are the motivation behind this. Right at the bottom, there's a toggle switch there.
John, got it. Okay. Can you hear me now? Okay.
You're good.
So I'm not sure I was the motivation, but I was kind of the guinea pig last year who was asked to basically, go into the future here a little bit and try to provoke some thought and discussion. And obviously, I'm happy to participate today and to see that there's kind of sustained and increased interest in this. My background, I basically worked, I was just doing the arithmetic, it's 37 years total in private industry. I started out with a small startup company, Allelix Crop Technologies, and if you remember them, well then you're basically my age peer. Back in 1988, when I was still in grad school, and from there, Allelix was acquired by Pioneer Hybrid in 1990. I worked with Pioneer in various breeding roles and then eventually became the global breeding lead for canola. And I also worked with sunflower and wheat a bit over the years. And, this is kind of the history of the seed business globally. Pioneer was acquired by DuPont, and then DuPont merged with Dow to form Corteva. And I survived all those things. And then eventually in 2020, I retired formally from Corteva, just the same month that basically the COVID lockdown started. And that was good because then I could work from home. I was hired back the day after I retired part-time just to manage some external collaboration. So just, I can't, or I'm not speaking formally for Corteva Agriscience, but that's okay. I'm speaking from the perspective of my 37 years experience in private plant breeding and specifically in canola.
Thank you, Dave. François.
Yeah, my name is François Eudes. I work for Agriculture and Agri-Food Canada. For the past 10 years, I had the function as Director, Research, Development and Innovation, overseeing our research sites in the province of Alberta. I'm located in Lethbridge at one of our RDC. And 3 years ago, there was a little bit of change in mandate assigned to the different director. I inherited a national mandate, breeding innovation in crop germplasm development, which enabled me to see the entire spectrum of research we do related to breeding, and certainly on the foundational science, thinking at all the omics work, the genetics, the plant physiology, worked on the microbiome as well, microbiome interacting with the crops. And before that, I was a scientist with AAFC. I led a science program on enabling technology, focusing on developing breeding tools for 15 years, with a goal to develop new breeding tools and establish intellectual property, patent these technology, license them. And I was focusing on application in small grain cereals. So canola is a new territory for me, and I'm very thankful for my colleagues at AAFC Saskatchewan in particular to share their knowledge with me.
Thank you, François. Alison.
Thank you very much. This morning I met Brad Bly, and he advised that he saw me in 2011 pitching with my former company and at the Danforth Plant Science Center. I started out life as an entrepreneur. I've had 2 different startups. The last one, I was an overnight success after 29 years of research and development. Divested my company to a UK private wealth firm in 2019 and started looking at all of the things that we needed in terms of being an entrepreneur in Canada working in agriculture. The 2 things that I saw that we needed were mentorship and access to capital. And that's all that I've heard today, perhaps, is how serious the lack of funding is. The one thing that I really wanted to emphasize is what I saw in return on investment. One of the things that I did is I started a venture capital fund that invests in deep science and tech in early stage. And I'm so amazed by the number of companies that I am seeing that are investing in this space. So very delighted to join you today.
Great. We're glad to have you, Alison. And last but not least, Peter.
My name is Peter Phillips. For the last 30 years, I've been professor at the University of Saskatchewan. Started in the department that Richard was in and ended up in the School of Public Policy. Before that, I was a professional economist in industry and government. I guess what I bring to the table is that I've spent the better part of my academic career and earlier when I was in public service trying to figure out how to accelerate the use of technology in a variety of sectors. But my particular interest is the technology of agriculture, and part of our research program that we had at the university was related to public-private partnerships. So I both helped create some of them, and I've studied them as an institution of advancing the use and development of technologies.
Well, we just have a great wealth of experience and different backgrounds and different perspectives. So I'm just going to talk a little bit more about what's driving the need for this session. So as you all know, it's been talked about this morning, farmers and Canadian taxpayers fund a significant amount of primary public research. But in the canola industry, we have this unique model where it's dominated by private breeders, your Bayer, Corteva, BASF, Nutrien, DL Seeds, etc. But there seems to be a bit of disconnect between the public researchers and their trait development and then integrating that great work into canola varieties that eventually end up on farmers' fields. So public and producer dollars are, often invested in genetic research to gain major advances in disease resistance. Of course, your clubroot, blackleg sclerotinia, verticillium, and your abiotic stresses, your heat stress, your drought stress. And I feel these are shared priorities, that everyone's aiming for the same goal overall. But that's where it seems like there's a bit of a disconnect and that sharing doesn't continue. So our goal here today is to have an open dialogue about sharing research priorities and exploring the possibility of a pipeline for innovation flow from the public researchers to private breeding programs. So how can we get that pre-breeding work, the traits, the novel sources of resistance, molecular markers to flow from the public system to the private industry more effectively so they can be incorporated into commercial cultivars that farmers are growing on their farms every day? So ultimately, farmers and public funds are investing in research with the goal of helping the farmer. And, in my role with RDAR, I see funding applications where the public researcher states, new germplasm and IP will be made available under an MTA and licensed agreements guided by the academic institution's policies. And that's a little nebulous, a little bit out there. Or something along the lines of canola germplasm could be developed that could have value in a breeding application, and it would be licensed to interested parties under negotiated agreements. So, I think that's where we need to have more dialogue and connection between the public scientists and the private industry so that we can do a better job. And, I think, how do we keep track of that? And if it does make sense for the public breeders or the public researchers to work more closely with private companies, what kind of pipeline do we build and what does that look like? So I am going to go to my panel, and I want to start with one of the successes. And François, I'm going to put you under the microscope first. Can you comment on some of the transformative traits that the public sector, either here in Canada or globally, have developed that are in today's canola varieties? Let's celebrate some of our successes.
Sure, and I'll try to highlight. I only have a few that comes to mind, and definitively first, I should say the public sector investment in foundational science has been instrumental in developing some of the key traits that you find today in modern canola varieties. And we heard a lot of this earlier this morning with the two speakers. That investment in foundational science, first of all, is an investment in creating new knowledge, additional knowledge, and building on what has been generated in the past. AAFC has been instrumental, especially this center in Saskatchewan, in that in reducing the anti-nutritional compound from rapeseed to develop canola. There has been also substantial effort here in Saskatchewan at AAFC, but also in European public research organization to develop herbicide resistance, and that includes Ghent University. INRAE has been instrumental in France in developing the male sterility, or identifying male sterility and the restorer system in order to establish hybrid system in rapeseeds in Europe and in canola in Canada. And that particular technology has been transformative because it also create a mechanism for a return on investment for the private company. And it really changed the face of the industry with the herbicide resistance. I'm thinking at also the reduced shatter, pod shatter reduction trait. Here too, colleagues here in Saskatchewan in the public sector have made substantial contribution, but it really took many groups to come up with a good understanding of that shattering trait and establish these traits in modern varieties. We heard a lot about the disease resistance, clubroot, blackleg, now verticillium also, where there's a significant investment within AAFC to create that knowledge that is needed and develop markers, selection, breeder tools to incorporate these traits in modern varieties. It's interesting to see how the earlier effort were focusing on single gene control traits, and now we're really at the stage where we're focusing on more complex traits that are regulated by minor genes. And it's much more complicated to bring these traits today to the hybrid canola. So lots of different traits, and I want also to mention the significance of the investment in genomics. Again, knowledge creation, but from genomic knowledge, generating the molecular markers that accelerate the cycle of breeding, this introgression of genes for resistance to disease, for example, but other traits as well as the double haploidy method, again, as a technology, a breeding tool that helps to accelerate the cycle of breeding to bring these traits more rapidly to the market.
Thank you, and I love the touch on, how the public sector helped develop technology to allow hybrids so that the private sector could have revenue generation. So I think there's some great wins, and you talk about how some of the low-hanging fruit has been harvested, and now we're, getting the ladders to get some of the more challenging stuff. So Alison, I'm going to switch over to you now. And can you, when we were doing our planning session, you talked about some of the brilliant orphan science and how there is the challenge of getting that from the public system into the private system. So can you speak to some of your experience with that and the challenges and some of the successes?
Sure. So, apologies. I'd like to broaden how we're thinking about collaboration. We often frame public-private partnership as a public breeders working with big companies. And there was a question just before the break about how could data and precision agronomy, how could that expand sort of our reach? And I think that that's one of the key things that's happening right now with data acquisition, data analytics, AI. We're going to start seeing a new layer of development coming about. There is a third group that's really actively trying to participate, and they're essentially startups and innovation scaling type companies. These are often built by the very scientists who have invested or participated at one of the public institutions. But it's turning into a very exciting space and an exciting time to be around. I thought that I'd make a note about one of the investments that I have made, and it's in a company called Colossal Bioscience. And it's focused mostly on human, but they're now crossing over into agri-bioscience. And if you don't know the company, it's actually the company that's bringing back the woolly mammoth. Now, why on earth would you want to do this? And de-extinction is probably one of the investment areas that I think are very, very interesting. Now, what makes this interesting is that this is a decacorn company. As of September, it had raised $10 billion. So if you're looking at a company like this, or a valuation of $10 billion and has raised $500 million for investigation, this is how exciting science, biology, and investment in areas like agriculture. When I saw the return on investment that we have from breeding programs, the average venture capitalist would salivate. Returns of this type are amazing. I think we kind of think of ourselves in agriculture as the orphan or the ugly stepchild, when in fact, we're the economic driver. And so I think for Canada, we have to understand that our possibility, our opportunity sits in rooms like this that talk about returns of wheat breeding programs of 70 times. The Human Genome Project returned 141 times every dollar spent. So I think we have to say that maybe breeding is actually pretty sexy, and there is financial return to be had. And that's just where I'd like to put that if we start pursuing some of these things, there's actually returns to be had.
Thank you, Alison. Are there regulatory challenges or?
Huge.
Could you maybe touch on that?
Huge. So we talk about two levels of research value, and there's a translational layer where startups really play, and that translational layer is IP protection. We heard a lot about that today. The regulatory uncertainty in Canada. It is an absolute drain on everything that we do from research. There's also a mismatch in expectations between growers, researchers, public breeders. And I think the biggest problem we don't fund in Canada is that translation, field trials, the work that has to be done to get these products to market. And the innovation continuum is not just invention, it's commercialization and adoption, and we have to fund the entire sphere.
Excellent, thank you. I'm going to now switch over to Peter. And, I think so far in our conversation, we've grouped public researchers in one basket, but there's definitely differences in those in academia versus those at AAFC, for example. Could you comment on some of the differences there and the challenges in innovation flow that each one would experience?
Let's take out of the calculation where they live and think about who they are. Who are you trying to motivate to do things that would be valuable to you? The first thing is they're not like most of the people that will talk about what we want to do in agriculture. They're lifetime appointees who are highly skilled in a relatively narrow area, and for the most part, they're driven by their curiosity. Now, their curiosity can only have value or be affected if they can generate money to do research. Increasingly, that's happening both in the public, that's always been the model in the university space. It's increasingly happening in the public space as well. So these people have a 40-year horizon as they think about what they do. They may start narrow. Many of them will broaden out and build very interesting integrated programs that are very transformative. But you have to work with the reality that they're not entrepreneurs. They don't want to be entrepreneurs. Most of them, the moment somebody says, let's talk about commercialization, they pack their bags or close their minds and walk away from the conversation. So you have to realize that you can't ask these institutions, the people in these institutions, necessarily to do what you would like to do. Now, what do they produce? They produce the background knowledge. They in the first instance, conserve it and make it functional. Then they transmit it through teaching. And so one of the biggest tech transfers, which we never talk about in agriculture and in the public space, is human capital. The wetware, the brains that walk out of those labs and work in the firms and industries and other segments of the industrial space are probably the single largest tech transfer from the public space, particularly universities, but to a lesser extent in the public labs. Occasionally, they trip over something, and I use that word deliberately, that might have some commercial value. There are a few scholars that are intrigued by that, but most of them aren't. They have to be cajoled into thinking about intellectual property. So what we do is often add on top incentives. The first one is money. We hand people money, but it's not money the way a scholar would like it. You know, I've watched people put up slides of the different priorities they have. That's what a scholar looks like too. A scholar's lab looks like as well. There will be virtually no lab that's 100% funded on a continuing basis. They're all having on a monthly or annual basis to recapitalize some parts of their research facility. And then they have to meet the conditions of all the different programs that are out there, and it's an alphabet soup of programs. I think in my career I had 50 grants. I had 45 different funders. They all thought they owned me. No, they bought a tiny piece of my research plan as I progressed. It has to be made relevant, and that fitting is the challenge. So we pull them a little bit from their primary interests by the money, and then we graft on top a whole bunch of institutional imperatives, intellectual property offices, tech transfer offices. So, you know, the disclosures and the filings, which academics may have to be part of, and public scientists, but generally that's not why they do the science. That might be a nice add-on, but it's not a core part of it. And in many cases, it's pushing away from the objectives of the primary scientists. Richard did a nice job of explaining what the public should be doing and what the industry should be doing, much of which is done with public or university research facilities. When we get pulled into things that have specific and commercial value, we've probably been pulled into the wrong space. So that we have to be careful about asking academics to do things that academics are not particularly good at or motivated to do. And money won't talk, because remember, these people have a lifetime appointment. If you're a scholar, you can stay till you die now. There's no mandatory retirement anymore. And they have 100% salary. It's not like in the United States where they live on 8 months salary and have to earn the other 4 months from their grants. So you need to find a way of motivating and engaging with them. And I guess the other thing I was asked to do was think about, is that all we've got in the public space? No, we do create very explicit, very, very focused public-private partnerships, but they live on the margins of the public and scholarly space rather than at the center. So at our university in Saskatchewan, Richard's done much of the work on this. The Crop Development Center is now over 50 years old. It has very explicit commercial objectives. Many of the lead scientists are scholars. They have academic standing, but their salary is paid for by their research. So they're in a hybrid world, which keeps them focused on the research and it keeps them away from the distractions of the academic community. And in that case, it's been extremely successful. It's generated many of the varieties and background to the varieties you use on the farm today. And its ROI is through the roof. So we can do that, but it's not going to be by changing the core structure of a university. It's by going to be finding these ways of hybridizing, taking the incentive structures that come from the marketplace or other places, and creating enclaves where you can undertake these different kinds of activities.
I really appreciate that recognition that our public scientists are curiosity-driven, and we can't ask them to be something they're not, but we need to provide the pipeline to connect them.
I'd add a codicil. At times, the public scientists and academic scientists grab a mission. They really want to do something. And many of the major transformative events in canola were just that. A few public scientists, both at universities and public labs, Ag Canada, NRC, took hold of a particular challenge, going to 00, creating transgenics that functioned, and you can go down the list. They were skunk works. So it is possible that at times there will emerge a group of people that want to do more than just add to the stock of human knowledge. They want to change something. And the challenge then is to offer enough free space that they can do that, and which means there has to be some redundancy in space, and similarly stop the barriers that, take down some of the barriers that stop people from doing that.
Great. So I think one thing I want to touch upon, and if anyone wants to respond, is, you talked about having 50 grants over your career, and as public research dollars get fewer and fewer, there's less ability to have some of that wide-spanning curiosity. So how do we, zone that into what those farmer dollars and what those public dollars are, going to actually be paid for, where they're going to be awarded to those scientists? So I think that's, we've got curiosity-driven researchers, but we can't forget when funding dollars are tight, how they do have to narrow that sense of curiosity, unfortunately.
I guess the one observation that I think is actionable is that grants can be very powerful motivators for people to look at things that you're interested in. But the way the grants are constructed these days, they're not particularly good motivators. The most competitions, the probability is 30% of success. If you compete, you can't win if you don't compete. And when you get a grant, sometimes the front end uploading startup will take 6 months as you negotiate agreements and startups. And then the wind down will be in 3 to 5 years. And you can't wait until the end of the 5 years to start thinking about your next grant. So there's a very narrow window where you're really focused on the primary focus. And as the grants get smaller, probabilities get less for success, and the timelines are shortening. It just means you're spending an awful lot of effort to get the focused energy of scholars and public researchers. And so lengthening, scaling up, reducing the number of competitive steps is probably, it may seem to the outsiders that that's a great way of controlling what people do with your money. It's actually a terrible way, because it's a very large deadweight loss on the advancement of the science itself.
Yeah, I agree. There is certainly a huge burden on the scientists to apply for funding, get the grants in place or the agreements in place, and then start thinking about the next one when you're still trying to work on the existing one. So big challenges. I want to now switch over to François. Agriculture and Agri-Food Canada has consortiums, which I understand are take a very targeted approach at a very specific problem. How have these achieved success in innovation flow?
Thank you for the question. First, I should mention that AAFC has diverse experience in building relationships with different stakeholders, including private company, and establish collaboration. So the consortium model is different from the other ones because it attempts to bring multiple parties who could be competitors in the market. So certainly thinking at the seed company, the company developing the hybrid canola, they compete. It's a very, very competitive environment. But the consortium offers them an opportunity to join the public sector, identify a common objective, something that is pre-competitive, that all parties would benefit from, invest to mobilize the science capacity that exists in the public sector in order to deliver a very tangible outcome. And the history over the past 20 years with the consortium has been research focusing on mostly disease resistance, so the club wrote, other disease, but also in genomics with the development of a NAM population, which in that case generate knowledge and eventually molecular markers, operating tools. So yes, what is unique here is, and the success to celebrate is our science experts who are engaging in the conversation with the private sector, representative of the companies, to bring them together so they all agree that there is a common good at working together, investing together to mobilize science capacity that exists in the private sector. So we had great success generating genetic material with resistance to this disease, as well, again, through the NAM population, developing molecular markers that have been adopted.
I think we all need to put on our thinking caps and give some thoughts to what some of those common good issues are, and have very trusting, open dialogue between private and public about what those objectives are, because that does kind of address some of those funding issues. And please respond.
Yeah, it's an excellent point you're making, because the success related to the interpersonal relationship and the trust that has been established. It's interesting to see that we tend to see similar names, certainly the more established, so senior scientists within AAFC, and who are playing also a leadership role in mentoring the junior scientists, bringing them on board on this consortium. But you see these names that are trusted by the industry, that enable the industry to come back in the next consortium.
Yeah, so I encourage the audience to do some thinking there. And I just want to cite an example where sometimes farmers and public funders look at a proposal and say, this is just great. And then we get an industry perspective on it and they say, well, that's not going to work because of X, Y, Z. And we go, we just all spent, researchers spent the time developing this, funders evaluating this. So how can we have those trusting conversations before, so that funding proposals are developed to hit the marks right off the hop there? Now I'm going to give a chance here to Jed and Dave to say a few things. And, not all models work equally well. I would love, we'll maybe start with you, Jed. What are your thoughts on examples of where things have gone well, and what were some of the elements of that led to success?
Sure. I think a lot of the elements have been brought up in some of the earlier answers. François just mentioned trust, so a lot of these partnerships do depend on a relationship, on a network, right? So we don't have a lot of formal structures for going shopping for a trait that private industry might be interested in. So it relies on events like this to bump into people that are working on something interesting. So that trust is a key part, and building out the networks and connections. And so the more sorts of things that we can do to facilitate that, probably the more opportunities we'll have to engage in these partnerships. Beyond that, some of the different structures, the consortiums were mentioned. There can be one-on-one relationships. They kind of dictate what the scale or the scope of the research is going to be, and they can depends on which perspective you're looking at. They can facilitate or hinder broad adoption of a technology. So one of the benefits of a consortium approach is if you're looking at something like a novel disease resistance, if you had a sort of a relationship between a private partner and an academic researcher, that private partner might get early or exclusive access to the trait, and then it's only available to farmers in a limited number of products, which can give a competitive advantage, and so from one perspective that could be a plus, but it doesn't necessarily help the industry as a broad whole. But something like the consortium model does have a better chance of delivering that innovation more evenly across the industry. The advantage from the perspective of a private company is that it also really reduces the cost and the barriers to entry. It means that the cost of the research is shared. There's more open information sharing to a degree between parties, and so that can be an advantage too. And public investment in research is declining. Private investment is not unlimited. So things like cost is a consideration. Some of the other barriers that can happen depending on the way these partnerships are structured are really around the intellectual property and the access rights. And those can be obstacles because it becomes a negotiation of how the benefits are shared out between the participating parties. And again, the consortium model, and it depends on the party that you're working with and the mandate. The consortium model with Agriculture Canada is a good one. It's very focused on a broad industry benefit. Sometimes when you work with universities or tech transfer offices, intellectual property can be seen as a profit center for them too. And so that structure, that arrangement, the negotiations, the discussions that we have there are very different, and sometimes they fall apart. But not always. But those are some of the landscape, I suppose, of how different partnerships can be set up, and some of the benefits and advantages or disadvantages to each.
I really like that we don't, you put that highlight on no formal structures for kind of shopping for traits. And maybe that's something we need to think about, is maybe we don't need something super formal, but we at least need an avenue.
It sort of came up tangentially even before the day started here. There was a little breakout around the different industry steering committees. Yeah. And one of the benefits of those is that they are a place where, on a topic, participants from industry, from academia, from public sector institutes, and from grower groups can get together and connect and share what research is going on, what the research priorities are, and that is one of those places where those connections can happen. And I think we need those venues to be able to just keep up on what's happening in all of these interesting curiosity-driven labs that might be useful and more broadly applicable.
Yeah, so I think maybe the encouragement is involvement of everyone in this room in those industry steering committees, so you are aware of what is going on. So even if you're not there, be very in tune with what they are saying is the need and who can deliver that. Now, Dave, we really need to let you have some time at the mic here. So similar to Jed, can you talk about what would make innovation flow easier from the public sector to the private sector?
There, I think we're on. So it's great to come later in the discussion because I can, I don't have to repeat things, and in fact, I need to avoid repeating things. One point I'd like to make, if you go back to the beginning, the motivation, I think we're all united, all scientists, it doesn't matter where you sit, even in what industry, by that innate curiosity and the passion for science. The second thing that unites us is a desire to see the thing that we spend months, years, sometimes a big part of our career on, actually have an impact, okay? Benefit the industry financially and benefit society as a whole, because those two are a continuum. So I think a lot of things have been covered here, very, very good points and areas that we can try to build on. Jed talked about, I think, a lot about the what. So the what is important because there's never enough resources to do all the things that are on our hit list. So we got to be very selective. So prioritization is important. Do we as an industry have that short list of key priorities and then go the next step and say, which ones are the best candidates for public and private working closely together? And then I think you kind of bridge into the how. So from the very beginning, defining what that effort looks like and what the roles of each party are, how can we synergize? And the real goal here is ultimately to deliver something, and if we talk about something where the deliverable has to go in a commercial product, onto a farmer's field, and we want to get it on as many acres as possible, as fast as possible, without impeding all the other things that factor into success in the industry, then how can we design a program, execute that program, and deliver the innovation as fast as possible? And so I think things like, how we design the program, so that we maximize the science knowledge and input from public and private, recognizing that private is always going to keep some things, close to their chest, and that's okay. There can always be a competitive element, even when we're working together on something. There's going to be pieces that are not shared inside the closet for each of us or behind the curtain. But then you come to, okay, what are the expectations? How do we assess progress in a dynamic way as we execute? And then ultimately, what are the terms and conditions that get that deliverable into the hands of private industry? And something that, I think Jed and I could say, that's when the hard work really just begins for us, because we have to integrate that into our own elite adapted germplasm and put it through the breeding machine and ultimately deliver hybrids, seed to the farmer. That's how they're going to benefit. And so those are all things that I think we can consider now. And I know every time I talk to Curtis, he raises verticillium as an example, and I think that came up in our pre-discussion. So if we use that as an example, and we step back and we start from zero, how could we design, let's say, a research project, I'll just call it that, multi-year, we could say it's open-ended in some ways, that would maximize the success, ultimately as measured by delivery of solutions to canola growers to deal with verticillium. I'm finished.
Yeah, I got this back on. So I think you outlined just a fantastic plan, and I'm going to just repeat it to make sure I've captured it properly. So I think having impact is that prioritization list of what does the industry need to achieve, and we have the laundry list, but what is number one, number two, number three, and then what ones of those things that need to be addressed really fit in the public-private model, and then how do we make that happen, and what are the terms and conditions of that agreement to making that happen? Is that a fair summary?
Sure.
So if we could build that, I think that would be fantastic.
Yeah, and just one more caveat. I mean, obviously, this is just a small piece of the total, kind of the innovation, universe that's constantly going on. So this is not saying everything has to go through a specific model, highly prescriptive. That's not where we want to go. But we want to say, okay, it's very practical. If we're going to work together on one or two major projects, recognizing that they're significant undertakings, they're really challenging. If there was already a simple solution, it would have been delivered.
Yeah.
Okay? Because private companies, we know, are highly motivated to each of us wants to beat everybody else and deliver the best solution, a durable solution, and keep building on that. Okay? The fact that there isn't one for a particular problem indicates that it's not simple. Doesn't mean progress isn't being made, but it's not simple. So that might be a good candidate, whatever that is. That's, there's all the rest of the stuff constantly going on outside of that. So this is just a part of the whole continuum.
Yeah, and I think from a selfish perspective, yesterday RDAR was in board meetings and we're evaluating CARP projects. And, when I can speak to one of the Canola Council steering committees having this as a priority, it really helps to get those public dollars investment and to give confidence to my farmer-led board in making those investments. So I think it's a really nice strategy for helping to invest public dollars and farmer dollars with some confidence in some of those big problems that we face. And yes, it won't work for everything. So one of the things that maybe an awkward thing is that when farmer dollars and public dollars are being considered for investment in a project, they always want to have evidence of where is the private part in this, how is this going to be commercialized, but then farmer dollars, public dollars, they don't want to, just hand a gift to, one company over another. How do the private companies put some skin in the game early in the process so that there, is that confidence that something will be commercialized, but that there isn't an unfair advantage to one company over another? And if that's too awkward of a conversation, I can understand that. But it's also a very real conversation at a lot of funding decision tables.
Take a quick step here. So with a lot of those sort of research priority things, I don't know that the goal is always that there should be something commercialized. So some of the research priorities are, Richard talked about this earlier this morning, more of the basic non-exclusive or non-excludable research findings. And as a private seed developer, we need to know some general information sometimes just about the environment. The disease surveys were presented yesterday. If we're going to invest R&D resources and effort into addressing a disease challenge, it's really helpful to know what is the trend line for that progression? Where is it showing up where it wasn't before? How much worse is it getting, or maybe it's not getting worse? We need a lot of that basic research. We need to understand, the biology of a pathogen and a host. We need to understand the physiology of stress responses if we're trying to develop things that are more climate resilient. So I don't know that, and that's all research that really I think is much better suited to being done in the public sector, and I think it needs to be valued more, and a focus on, we're going to put research money in here and we're going to expect 10 years, 20 years there's going to be a commercial payoff, limits the opportunities and the possibilities for collaboration. But yeah,
I think that was great, and thank you for being willing to respond. And I think Alison here.
So as the commercially focused person on this panel, I would suggest that everything we've said is correct. However, grower dollars are probably dollars that should be spent to solve the problems on the farm. And public dollars are spent on discovery and driving that engine. And I think we have a really big problem in Canada, is that we have such a fragmented funding system. And it's so focused on project base. It's episodic, 3 to 5 years. If we looked at RDAR funding, it's a project-based funding. All the problems we're talking about are 10 to 12 years, investments of at least $25 million. And we're so fragmented. And if you take a look at the Australian example that was raised this morning, the reason why that's such an effective funding program is because it's national. And if you look at all the levels of funding that we have in Canada, we're just not joined up enough. So we need that strong discovery engine. I don't disagree with that. But we also have to have this focused, non-fragmented way of solving big problems. Because if we look at some of the problems we've talked about today, those are 12-year problems. Those are problems that are confounded by climate, by many, many different things. And so we have to join up, and we have to think about how can we solve these problems differently.
Yeah, and I don't disagree. The funding timelines are constraints and challenges that we face, and and I think growers' dollars face them too when there is concern about drought, or in the pulse industry, maybe there won't be peas grown next year. Where's the levy going to come from? So there needs to be a lot of openness and dialogue between funders as well to address some of those really big problems.
That we're also not thought of as a strategic sector. If you look at, and I don't know why, I mean, we have to eat. Why is food and agriculture not strategic? We have AI, defense, EV. When did that become a strategic priority? So I really think that we need to have a better vocal conversation about the importance of research in agriculture.
I can't agree more. The need for a strategy, when I go back to my board, I'm always asked, how does, you said RDAR funds projects, and I am asked, how does this project fit into the bigger strategy? And when that strategy doesn't exist in a clear way, it's really hard for me to sell it that way. So I think that's a job of everyone in this room, to sit down and have those conversations about building a strategy. And I know Council's a great lead in that space, and we need to have more dialogue about where we all fit into that big mechanism.
The GRDC funding model is a 10 to 20 year funding model. For every farmer levy dollar that's put in, it is matched publicly.
Yes. So there we have a political layer too that I think has to be part of the strategy as well. So not easy problems to solve within this room, but if we can identify and name the problem, as Jay put into his his understand the problem, I think that's critical. So I know we've got about 17 minutes left, and I want to just go back to the concept of consortiums, because I think it has been a success story for Agriculture and Ag-Food Canada. Peter, do you see a way that we could integrate both Agriculture and Agri-Food Canada and academia into some sort of a consortium model, or do they simply have to be independent?
Yeah, let me answer that in a couple of different ways. I mean, we've had past examples. Some of them have withered. There's not as much engagement between the academy and the two major federal research facilities, Ag Canada and NRC. They've all been important in our lives. Some of our partnerships, like the CDC, do at the operational level engage with them at the investigator level, at the technological problem level. That's at least a start. Most grants, you can bring on a federal facility, a federal colleague. That's a waste of time from the grantor's perspective. They won't count it. They put rules in place that make it hard to do research with public facilities, public actors using private or using tri-agency or other centrally managed funds of engagement. That's sort of where we are. The GRDC model is our model. Let's be honest. We created that model in 1989. It's called the National Centers of Excellence. They took it and improved it. Our model was 7-year grants, renewable, industry and academy, large scale, but we made it so that federal and provincial partners couldn't contribute. They had to stay outside the room. Australia said, that's a great idea, but why are you isolating the federal, the government space? Because they're important. So they brought them in the room, and then they said each one's 7 years, but they're infinite. I haven't looked as explicitly in the ag space, but in the mining space, which I have investigated, they've had 13 cooperative research centers funded in the same way as the GRDC. They've generated about $800 million for research, which is why every major mining company in the world is Australian, because they found a way of motivating research. There's nothing to stop us from doing it. It's actually our model. It still exists on the books, but we've refused to make it work. So there's a model we could do. If I wanted to be more challenging, there is a model. There's a lot of people who say Ag Canada's at risk, and maybe parts of NRC, because they seem to be disconnected and having difficulty demonstrating a value proposition. Already in the federal budget, there's going to be a cut of 15%. And usually research is easier to cut than support payments. So the risk is that more of it will rely in the research area. Well, other countries have gone through this. I wouldn't recommend the British model of just privatizing. That was a failure, as far as I can understand from Richard's work. But the Dutch had a different model. About 20, 25 years ago, the Dutch government said, why are we doing all this research with bureaucrats? They're sitting in buildings adjacent to universities, and we're neither satisfying the research agenda nor the public agenda. So they essentially took their research facilities and handed them over to universities and said, make it work. Now, that didn't just make them academics. It changed the culture in many of the universities that got the research labs. So in Wageningen, which was a mid-level good university in Europe, it's now the world's best agri-food research university by all the metrics. What happened is they moved these research groups into the university, but these people were used to working in hierarchies and having management. And while the university says we have hierarchy, we don't. Every academic's a self-employed entrepreneur. We have presidents and vice presidents and deans and heads and all those things, but they can't tell anybody what to do. They have to incentivize them, encourage, cajole. Whereas in the research groups I've worked with in Wageningen, the professor sets the agenda. People have to have work plans. Most academics don't have work plans, they have projects. They don't have a 5-10-year work plan towards a goal. So here's a way of transforming one institution or one part of the world has transformed not only their public space, but their university space to advance research. And I guess that's the most aggressive of just slam them together and hope that, enforce that there's a cultural change in both institutions, not just in one. And I guess the last one is that if you can't do any of those, it's possible to do missions. The more colloquial term is moonshots. Decide something that will move you not incrementally towards a better future, but transformatively towards it. Something that you can't do now, but in your wildest dreams, if you could do it, that would be the best thing that could ever happen. And then invest some money in it. But invest it in a managed way. You don't give it to a bunch of academics to do. You have a project manager, like in DARPA, where they allocate 2 projects that advance the agenda. But at the end of the day, if your project isn't advancing, they fire you, and you're done. Grants are never truncated. Genome Canada tried for a short period of time to truncate grants, but it's become more of a soft review rather than a hard review. So these are all different ways we can help to change the incentive structures and move us towards a more aggressively financed and aggressively motivated research community.
Excellent. So I hear that we need inclusiveness between funders, and we need cultural changes at institutions. And one of the things when I was in Australia with GRDC was the model where they put forward, this is what we need you to address, researchers, and you bid on it. So I think flipping that to look at it a little differently is a really compelling idea there.
I think there's something that has to be added to the Dutch story, and that is the Dutch story is a triple helix. It's not just academia, it's academia, industry, and government, and they're focused on a clear path forward. The other sort of statement that was made on mining, the reason why mining succeeded so well is there was a flow-through tax structure that enabled investment to occur. We don't have a similar type of incentive structure in agriculture for those outside the industry to really understand how you can invest.
Yeah, I agree. There need to be incentives for that industry investment through a tax mechanism. Okay, François, maybe could you comment on your thought on the consortiums having very narrow focused objectives? Is there a way to expand that, or is that something worth pursuing?
Well, I would love to see expansion of the science activities under the consortium. I want to, though, before I go further, let's make a couple of points. AAFC has an economic and science mandate, so both of them. And when we recruit our scientists, we often say we recruit them for 35 years. And we make sure to connect them with the industry. We often introduce them to the stakeholders. They have long-term mandates, so they know they can, I don't want to say just to say they can take time. They know they can work on a mandate over many years and achieve impact through this continued commitment. Yes, there's a problem with the cycle of funding, but I think many of them are successful and find a way in the storytelling to speak about what can be achievable in a 3 years or 5 years funding cycle. So thinking of the clusters in Agriscience project that provide funding for up to 5 years. And to be able to go back with the success of the previous cycle of funding to request additional funding to continue that either knowledge creation or leverage that knowledge to create tangible outcome for the sector. So there are many science areas where AAFC science experts have done groundwork and moved the knowledge to a point where it reduces the uncertainty in taking that innovation to the next step. So verticillium is an example. We already invest substantially. We have created substantial amount of knowledge that help us make better decisions for the next type of investment that could be made. So there could be a consortium on that particular disease, but it would be interesting to see that the consortium have focused essentially on bringing this disease resistance into the Canadian canola genetic material. So does it mean that the industry see only the value of the public sector in this particular area, generating resistance to the disease, to the biotic stressors? There is abiotic stressors as well. There are a number of other traits that the producer could benefit from, thinking of nitrogen use efficiency, nitrogen biological fixation. There might be also attributes to focus on where the industry would be benefiting. So I think there's much more than what we are doing today, and I'm wondering how we can expand that circle of trust so we can talk about this idea for our AAFC scientists to speak about the maturity of the innovation, and hopefully some of them are at a level where the conversation with the private sector would be instrumental in mobilizing the private sector capacity as well to take this innovation to the next level.
Excellent. So I was supposed to leave 10 minutes for questions. Did you want to say something quick, Jed?
I like a lot of what François is saying about, there's been a narrow focus on the public sector developing a trait that private industry deploys into the market. But that's, the things that you're talking about, nitrogen use efficiency, abiotic stress, those aren't a trait, right? And we need to rethink how we can leverage the expertise and the foundational research that's happening in that public sector to enable breeding and develop some sort of enabling technologies that go beyond just, the deliverable is an envelope of seed that we start to breed with, because that doesn't address a lot of the challenges that we face.
Yeah, great point. And I think that's something we have to explore in our conversations. So, Jay, do you have a question or two for us? And just to remind everyone that we will have lunch, and then we will be coming back to give some last thoughts. So let's hear what Jay has from the audience.
There's a few coming in through Slido, and this one's got 4 votes now, so we'll go with it. Has there ever been an emphasis made on increasing efficiency and/or identifying inefficiency in research? You want me to say that again?
Yeah, I think we got to process that one more cycle through.
Has there ever been an emphasis made on increasing efficiency and/or identifying inefficiency in research?
So how can we increase efficiency?
Well, maybe a brief comment. I've been a scientist, and I know that my colleagues today are in the same boat. Everything they do is peer-reviewed. They develop an idea, has to be peer reviewed to secure funding. Annually, they have to submit report to demonstrate their progress, the financial report as well, and it's reviewed. Every knowledge communicated in scientific journal is also peer reviewed. So when, if a scientific team is not hitting the mark, has the opportunity to explain why, made some correction, but certainly there is a mechanism to assess if the science is delivering what it had committed, and including if it's underperforming.
Maybe I can add just a wee bit to that. Yes, as part of the gains to research literature stream, people look at efficiency and effectiveness of a variety of sciences. And they tell you something, but there also are sort of meta studies of research systems. One of the ones one of my doctoral students looked at was actually in canola, as we went from public research that was 100% public funded to the matched research programs. What we noticed was macro terms, the citation rate for the quality, which was a measure of the quality of the research, went down. And we were curious what was going on there. Was that because not everything was matched funding at that point? What we discovered is that it actually went up for a subset of funding, matched funding. And that was projects that had 2, 3, and maybe 4 partners, but one partner was a bad thing. That diminished your ability because you were sort of in a locked, narrow problem-solving space. And if you had too many, you were actually dissipating energies in trying to satisfy too many voices. So there are ways of getting to more efficiency, but I think in many ways, if the question is driving us towards let's make our house more efficient so we can get more money, you're already down to a vanishingly small portion of the necessary funds to become an innovative sector. And Richard showed us come from 2.5 to 1/2. Let's be perfectly frank. The innovation sectors in the world are investing 1/3 of their gross value added in R&D. That's the ICT world. The top firms in the agri-food supply chain, greater than 10%. So farming is that Canada's not carrying its own weight in this space. And the risk is that over time your productivity, while it may still go up, might not go up as fast as everybody else's, and that pulls resources away from our sector. So I think efficiency and effectiveness, yes, you don't want to ignore that, and I think the systems drive much of that. But the more important question is, how do you justify to yourselves and to others to actually invest more?
And maybe I'll just make one quick closing comment on the efficiency pieces. I think sometimes with capital investments in technologies that can make assessments more automated or things like that, those are efficiencies that can be gained, but sometimes it's very hard to secure funding for those in the private research or in the public research world, whereas the private sector, I think sometimes public researchers are looking over the fence and going, I'm kind of jealous of the efficiencies they have with some of the technologies they have. So with 5 seconds left, I am going to pause it there, let everyone enjoy lunch, and then we will come back. Everyone's going to make some closing comments, and if there are some great lunchtime conversations and things that come up, let's feed those into Slido, and Jay can see them and upvote them. So thank you very much to all the panelists.
Thanks, Sheri, for moderating. Thanks to all the panelists again. As Sheri was saying, we're going to be meeting for 30 minutes after lunch. And so to conclude this, and before we go for lunch, I'd just like to make a quick comment, and I said it yesterday, but I'm really, really thankful as a farmer and and also as a participating public research as well at University of Manitoba for the vibrant private sector that we do have in Canada in canola. I may be getting my numbers wrong here, but I think about 10 years ago, we were doing evaluation exercise exactly around some of this ROI, And I did some back of the napkin math, and I think our private sector in Canada invests about 18% of their gross revenues back into research, and much of that stays in Canada. So that's an incredible platform of funding too that we can rely on, and a lot of our private sector scientists participate and give a lot of their time to some of our key initiatives like the WCCRC, et cetera. So we do have an incredibly vibrant private sector in Canada. And it's something that I think we're all hearing, we need to build on that effectively and leverage that as both government academics and government scientists and academics. So with that, sort of with that talk about the private sector, I just like to ask Dave Kellner from Bayer to come up and say a few words. Bayer is sponsoring, and so you can turn over the mic to you before we go for lunch.
Okay, thanks, Curtis. Just a quick word. So yeah, Dave Kellner, canola portfolio lead with Bayer, based in Calgary. And if you're not sure who Bayer is, we are a seed and crop protection company. We're heavily invested in canola. We breed canola hybrids, and we also offer seed treatments, fungicides, and herbicides to protect the crop. So a full suite of crop protection products to complement the hybrids. So in the spirit of future development of canola, we are sponsoring a little poll. Hopefully it'll be a fun poll. There's a QR code on your desk on the placard, and that will take you to a link that will ask you a number of questions, hopefully thought-provoking about future priorities for canola. And it will also enter you in a draw to win an iPad, which is also a fun part of the poll. So as we think about the future of the crop, we're thinking about a truly connected canola system where genetics, agronomy, and digital intelligence all work together to improve the profitability of canola for the farmers that ultimately are the producers of the crop. And coming together at conferences like this one at Canola Week, I think, is a really important step in helping build out that future. So with that, enjoy your lunch, and good luck in the draw.